In this video, I'm going to explain to you what platform engineering teams do and what service they provide to the rest of the organization so that you can decide if platform engineering is for you. First, I will clarify what is meant by a platform. Then I will talk about the three main responsibilities of platform engineering teams, which are 1. Provisioning and managing platforms, 2. Providing CI/CD tooling and automation, and finally, governance. Let's get to it. Welcome to the Platforms and Beyond channel, the #1 place for best practices and tips for DevOps, platform and cloud professionals. If you're new here, please hit the subscribe button to be notified when I publish new content. So what is a platform? A platform is a system that includes software and hardware to provide a specific service for business applications such as runtime, messaging, monitoring, or a login service. Generally speaking, any system that supports the life cycle of an application from testing to deployment to operations can be considered a platform. Platforms can be thought of and categorized based on the type of service that they provide. For example, runtime platforms offer the environment for running business applications. On the other hand, messaging platforms provide means for applications to communicate with each other via message passing of some sorts. Monitoring platforms offer means for collecting and visualizing application metrics. Platform services can be deployed either on-premise or in the cloud. That's another way of categorizing platforms based on how they are provisioned. In addition, platforms can be self-managed or purchased as a service, in which case they're called platform as a service or PaaS in short. Let's take a look at some example of platform technologies. Here are some popular platforms that you might be familiar with. For runtimes, there is Kubernetes and container-based runtimes, such as AWS, ECS, and Fargate. For monitoring, you'll find Prometheus and Grafana are the de facto favorite platforms for monitoring and alerting, particularly in Kubernetes environments. Messaging platforms, on the other hand, include Apache Kafka, RabbitMQ, Amazon SQS, Google PubSub, and the like. For data-oriented applications, platforms such as Hadoop, Spark, and Flink provide batch and stream data processing at scale. Generally speaking, any system that supports the life cycle of an application from testing to deployment to operations can be considered a platform. So what platform engineering teams do and what value they provide to the rest of the organization? First and foremost, platform teams provision and manage platforms. Platform teams are responsible for the planning and provisioning of new platform technologies and the provisioning of new instances of platforms already in use. A typical example of this is spinning up a Kubernetes cluster in a new region when a business is expanding operation in different countries. The process of provisioning a platform consists of deploying infrastructure resources like virtual machines and network components, followed up by the installation of any required software to run the platform service. For managed services, the provisioning process may require less steps since the service provider will usually be managing the underlying infrastructure and software. Once the platform is provisioned, platform engineering teams will carry the responsibility of managing the platform and looking after the three areas of availability, security, and cost. Let's take a look at typical activities in each area. For security, there is role-based access control to prevent unauthorized operations. Also part of security, we find firewalling and network access control. For availability, there is performance monitoring as well as capacity monitoring to ensure that adequate resources are available to the applications. Redundancy and disaster recovery, on the other hand, help with resiliency and enable platform teams to recover data and runtimes in the event of an incident. Finally, for cost management, typical activities include cost monitoring and the implementation of cost-saving measures such as adjusting the size of an underutilized database. The second responsibility of platform teams after provisioning and managing platforms is to provide CI/CD tooling and automation that supports developers throughout the entire life cycle of the product or feature. Tooling and automation is one of the most critical things for improving productivity and efficiency because automation promotes self-service and autonomy by reducing reliance on other teams. Let's take a look at typical operation and stages in the software development lifecycle that benefit from tooling and automation. At the early stages of the feature or product lifecycle, Platform tooling and automation facilitates the building and publishing of artifacts such as libraries or Docker containers. Ideally, developers shouldn't be concerned with the details and the setup required to publish these artifacts. All that should be handled by the tools and automation that abstracts these details. Testing and running code quality checks is another area where automation is crucial. Generally, this is the responsibility of QA teams, but platform teams often cover some of these aspects as well. The deployment step is where automation and tooling can abstract the details and technical intricacies of deploying secure and highly available applications. Developers should only be prompted for basic parameters such as Docker image, path to application secrets, IAM roles to use, etc., and not worry whether configuration and the artifacts required for deploying their applications on the target platform are accurate or up to date. The provisioning of cloud infrastructure resources by the dev team is also another area where automation and tooling can help a great deal by making the state management transparent to the teams and to ensure that the company policies are enforced, for example, by automating tagging and performing checks before provisioning a resource. Finally, when services are up and running, automation around monitoring and troubleshooting allows teams to respond to incidents much faster than having to rely on platform infrastructure engineers to intervene. An example of monitoring and troubleshooting automation are ChatOps. ChatOps can have predefined commands to visualize the status of an application and, if necessary, perform maintenance operations such as restarting a Kubernetes pod or fine-tuning application resources like increasing the size of a notice scaling group manually or increasing memory or CPU of a Kubernetes pod. Take a look at the third area of responsibility for platform teams, which is governance. Platform teams play a key role in setting and enforcing policies related to the use of the platform and the software engineering lifecycle as a whole. This is not surprising since platform teams are the most familiar and with the most control of runtime environments, CI/CD processes, and resources used by the product team. The platform team often helps in setting policies related to security, availability, and cost. Beyond setting policies, platform teams also help in managing compliance and developing compliance reports to help identify violations. And when required, platform teams can introduce automation to enforce compliance, for example, by blocking the provisioning or deployment of resources that are not compliant. There you have it, friends. I hope this was helpful. If you like this video, please subscribe for more. And if you have any questions or comments, please reach out via the comments section below or by email, which is in the description. See you in the next video.